Hello and welcome back. In this video, we are going to discuss the second angle property, and that is about angle in a semicircle. First of all, what is a semicircle? Semicircle is basically half of a circle. A diameter divides a circle into two halves, and that are known as the semicircles. So this property states that angle in a semicircle is always a right angle, mean that is always a 90-degree angle. So first of all, as we have a diagram, there is a circle with center at point O, and here we can see a chord AB that is passing through the center O. So that is definitely a diameter. So it divides a circle into two semicircles. So we have taken a point P on the semicircle, and the angle in the semicircle, that means the angle at the circumference of a semicircle, that is always a right angle, that it is a 90-degree angle. So similarly, there is a point Q over here in the lower semicircle. So angle at point Q will also be a right angle. Like first we join the end points of the diameter with the point on the circumference, and the angle at that point on the circumference is always a right angle, a 90-degree angle. So that is the second angle property. So here is a diagram of second angle property, and here is the abbreviation for this property, that right angle in a semicircle. Here is the actual diagram for that, and the statement for the property that angle in a semicircle is always right angle, that it is 90-degree. So let us practice practice now 7, where it have two question 1 and 2. It states P, Q, R and S are 4 points on circle with center O. We can see the point P, Q, R and S over here on the circumference, and O is here, which is center of the circle. Given that POS is the diameter, because it is passing through the center O, so it is definitely a diameter, and RQ is parallel to SP. We know SP was the diameter and RQ is the line segment over here. So these two sides, RQ and SP, are parallel to each other as they are shown by these arrows. SQR angle is equal to 35 degrees. It is mentioned over here in the diagram that this angle is 35 degrees. We have to find angle X, angle Y and angle Z. So first, locate the angle X, which is over here, and this is angle made with the diameter PS. So as PS is the diameter, so the angle at position Q, the angle PQS will be a right angle, because that is angle in a semicircle. So angle PQS is a right angle, 90-degree. Then in order to find the angle X in this diagram, in this triangle PQRS, we need the angle over here, the angle PSQ, and angle PSQ will equal to 35, because we know if RQ is parallel to SP, then this side, this line segment QS will act as a transversal, because it is passing through the pair of parallel lines, and the angle PSQ is alternate to the 35, so they are definitely equal. So it is alternate to angle SQR. SQR. So this is 35. So X shall become 180 minus the sum of other two angles, 90 and 35. After we subtract it, X shall become 55 degrees. So angle over here, it is 55 degrees. Now, coming to angle Y, we can locate it over here. It is angle at the center, and we know Y equals, the name for the angle Y is SOR. SOR angle, and definitely it is subtended by the arc SR. Now, in order to figure out the angle y, let me clear the area first. So the angle y, which is subtended by the arc SR, we can say that we can see that angle SQR is also subtended by the same arc at the circumference. So y must be double the angle SQR, and we know SQR was 35, so it will become 70 degree because y is angle at the center and angle subtended by the same arc at the circumference is 35 degree. So that is the value of angle y. Now we move to the angle z. We can see angle z is over here. It is it can be named as angle RSQ. And in order to figure out the angle RSQ over here, once again, as we know the angle adjacent to this is 35 degree. So I can say that the angle OSR is equal to Z plus 35. As we know, the triangle ORS is an isosceles triangle with one angle at O, that is 70 degree. This is position O, this is R, and here is the angle S. So because OR and OS are equal, being radii of the same circle, so the angle over here, these angle ORS and angle OSR, these two angle will definitely equal. And how do we find the base angle of a an isosceles triangle? It is 180 minus the vertical angle, which is 70 degree over here, divided by 2. So 18, it is 110 divided by 2, which is 55 degree. So 55 degree shall equal the Z plus 35, because angle OSR equals Z plus 35, which means 35 plus 20 is 55, which means Z is equal to 20 degrees. So that are the three values of the unknowns: X over here, Y over here, and Z is the angle 20 degrees. So this was the first one. Let us discuss the second question after clearing all this area. Let us move to the part 2 of this practice now. It states P, Q, R and S are 4 points on the circle with center O. We can locate these points over here, P, Q, R and S. Center is O, and given that POS is the diameter, because we see this line segment is passing to the center, so it is a diameter. Then it states PQ is parallel to OR. PQ is over here and this is parallel to OR, which is over here, and it is shown by the symbols as well. Then it is stated that ORS angle is equal to 65 degrees. It is also mentioned in the diagram, and we are to figure out three angles: angle OPR, angle QOR, and angle PXQ. First, let us talk about the angle POPR. And angle OPR, if we can locate it, lie over here. So in order to figure out this angle, I will like to start with the angle at position R, because we know that PS is the diameter of the circle. So angle at R, which is angle PRS, angle PRS must be 90 degree, because that is angle in the semicircle. And as we see, this is actually equal to 65 degree plus the angle ORP. So angle ORP must be 25 degrees, because 65 added to 25 will become 90 degree. So the angle over here it is 25 degrees. As we see, the OPR triangle is an isosceles triangle because we know the sides OP and OR are equal. OR and OP both are the radial segments. So the angle OPR also equals angle ORP, which was 25 degrees, and it is because of the isosceles triangles. So that was the first part. Then it is stated that find angle QOR, and if we look at this angle QOR, it is over here, and it is formed at the center O by the arc QR, right? So we can see that same arc QR is subtending an angle QPR at the circumference over here. So I can say that angle QOR being angle at the center is 2 times the angle QPR being angle at the circumference. So first we need to figure out this angle QPR. As we know the two lines over here, like QP and QP over here and OR over here are parallel. So the line segment PR which pass through these two parallel lines, it will act as a transversal. So if the angle over here was 25 degree, so the angle QPR is alternate to that. So angle QPR is also 25 degrees. And why is it so? Because that is alternate to alternate to angle ORP. So the angle QOR shall become 50 degree QOR. So the first two parts are done. Then we have to find the angle PXQ. So in order to find the angle PXQ, which is located over here at position X, let us first draw this triangle. This side is, let's say it is PQ, then this one shall become Px, and here is the Qx, point Q, the point X, and the point P over here. So we already know that the angle at position P was 25 degrees, as we have used it in the previous part. We have to figure out the angle over here at position X, and before we figure out this angle, we shall know this angle PQX. So in order to figure out the angle PQX, or that is angle PQO, we can use the fact that the angle PQX is alternate to angle POR, because we can see that OQ is a line passing through the two parallel lines PQ and OR, and these two angles are actually the alternate angle, and we have figured out this angle in second part. This was 50 degrees, so the angle over here will also be 50 degrees. So I am going to mention it over here. So I have the two angles, uh, 25 degree and 50 degree. So third angle, the angle PXQ shall become PXQ will be 180 minus the sum of other two, 50 and 25. So after we add the two and subtract the sum from 180, it shall become 105 degrees. So that is the value of angle PXQ. So that was the practice now 7, which was quite relevant to the second property. So in coming video, we will discuss the third angle property and its examples.